Section 13.8 is titled Counting Outcomes. You'll notice we are skipping 13.7. The objectives for this lesson, you don't need to write these down, are to use the tree diagrams or fundamental counting principle to help us count outcomes and find the probability of an event. So the first vocabulary term, which does need to be written in your notes, is a tree diagram. And this is simply a diagram that we draw to help represent possible outcomes, and it branches like a tree. So the first example, which remember does need to be written into your notes, is to draw a tree diagram to determine how many fish tanks can be made from 3 size choices: small, medium, large, and 2 shape choices: pentagon and rectangle. So when we draw a tree diagram, this time we'll start with the 3 size choices. So we had a small, a medium, and a large fish tank size that are options, and then they can either be a pentagon or a rectangle. So that means that the small fish tank could be a pentagon or a rectangle. The medium fish tank could be a pentagon or a rectangle, and the large fish tank could also be a pentagon or a rectangle. Now when you're looking at an example like this where the numbers are small and there aren't a lot of options, it's easy to make a tree diagram. What you're going to find though is when you have more choices that it's a lot more difficult to draw a tree diagram. But in any instance, here you can see that we could possibly have built 3 different fish tanks: small pentagon, small rectangle; medium pentagon, medium rectangle; large pentagon, and large rectangle. So we've determined that there are 6 fish tanks that can be made. Now I want to talk about the fundamental counting principle, and this basically relates the number of outcomes to the number of choices. And you do need to write all of this down. This concept here in the middle in this blue comes directly from the textbook. What this says is if you have an event that can occur so many ways, followed by another event that can occur so many ways, then the 2 events, m followed by n, can occur in the number of ways found by multiplying the first event by the second event. And in the example, which also needs to be written down, it says if there are 4 possible sizes for fish tanks and 3 possible shapes, then there are 4 times 3, or 12, possible fish tanks. Notice that example, the numbers are a little larger than ours. We had 3 possible sizes and 2 shapes in our last example. So essentially with the fundamental counting principle, you're just multiplying the number of outcomes, or you're multiplying the number of choices together to get the number of possible outcomes. So let's use the fundamental counting principle on number 2. We have a pizza shop with regular, deep dish, and thin pizza crusts, 2 different cheeses, and 5 toppings. So how many different 1 cheese, 1 topping pizzas can be ordered? So we're going to start with the crusts. There was regular, deep dish, and thin pizza. So that's 3 crust options. Remember, the fundamental counting principle is going to tell us to multiply. We have 2 different cheeses, and we have 5 different toppings. So when we multiply that together, that's 30 different 1 cheese, 1 topping pizzas. And this is much simpler than doing a tree diagram, because in a tree diagram, I'll just show you one little branch of it quickly, but if we had regular, deep dish, and thin, then the regular pizza, there are 2 different cheeses. So we could have cheese 1 and cheese 2. Then to add to that, now we have 5 different toppings. So for each one of those cheeses, we have to have 5 more branches. So you can see how difficult it could be to make a tree diagram. The fundamental counting principle here is much simpler. In the next example, and again you should be writing this down, so if you need to pause the video before we work through it, please do that. But we're going to use the fundamental counting principle again. So Shelly goes into school. She could walk through 4 different doors. Once she's inside, she can get to her locker by using 4 different sets of stairs and then 3 different hallways. So the question is, how many ways can Shelly get from outside the school to her locker? And again, the fundamental counting principle, we are multiplying all of the different options, choices, to get the total number of outcomes. So 4 different doors, 4 different sets of stairs, 3 different hallways. 4 times 4 is 16. 16 times 3, if you want to do some side work, is 48. Remember though, you can use a calculator. So there are 48 ways that Shelly can get from outside the building to her locker. Here we have the probability of randomly choosing a 5-letter password for an internet website that consists of only vowels if each vowel can be used more than once. So first we have a 5-letter password, and I'm going to just make some dashes here for our password. So it can be any 5 vowels, and it says we can repeat or use a vowel more than once. So let's talk about just the first position here. How many different letters can go in for the first part of the password? And your answer is 5, because there are 5 vowels. And let's write them over here: A, E, I, O, and U. So then for the second spot, how many different vowels can go here? Well, again, since we can repeat, we have A, E, I, O, and U, all options. In the third spot, again, since we can repeat, 5 vowels. 5 vowels for the 4th place and 5 vowels for the 5th place. The fundamental counting principle tells us to multiply all of those 5 together. This is the same thing as saying 5 to the 5th power. So 5 times 5 is 25, times 5 again is 125, times the 4th 5 is 625, and times the 5th 5 is 3,125. So there are 3,125 different passwords that can be made using A, E, I, O, and U in a 5-lettered password. Finally, we have a situation here where we have 2 different spinners, and we're going to spin each one of them once. So what's the probability that we spin red and the number 9? So the probability that we land on red and the number 9, the fundamental counting principle tells us to multiply those 2 probabilities together. So first let's look at red. What's the probability that it's going to land on red? And you can see that each of these colors is equally likely to occur. So 1 red out of 5 colors. So first, to get a red, it's 1 out of 5. And then to land on the number 9. So on the second spinner, we have 10 spots. One of them is a 9. So the probability that you spin red and the number 9, we have 1/5 times 1/9, and that's 1 out of 45. So 1 out of every 45 turns spinning the left and right spinner, its probability is 1 out of every 45 times you land on red with the number 9. So we used tree diagram and the fundamental counting principle to count outcomes. And in the last 2 examples, we use them to find the probability of an event. Now, tree diagrams are not as convenient as the fundamental counting principle, but it helps you to see why the fundamental counting principle works. In class, we'll work on worksheet 13.8.